All right, so this is Business Calculus 4.2 Part 3. And we're just going to wrap up this section with a couple more examples on where we use exponentials and logarithmic equations. So the next one is carbon-14 dating. And all things absorb small amounts of radioactive carbon-14 from the atmosphere. And when they die, the carbon-14 stops being absorbed and decays exponentially into ordinary carbon. So what we can see is that the portion of carbon-14 still present in a fossil or other ancient remain can then be used to estimate how old it is. So the proportion of the original carbon-14 that will be present after T years is given by this formula right here. So the proportion of carbon-14 remaining after T years is equal to e to the negative 0.00012 T. Okay? And so if we know what the T years is or what the proportion is, we could then figure out either how long or how old something is or how long it's been or what the proportion is. If we know what the proportion is, we can figure out how long it's been there, or figure out the proportion if we know how long it's been. So, using that information, we're going to use the formula to look at example 12. In Dead Sea Scrolls, the Dead Sea Scrolls discovered in a cave near the Dead Sea in what was then Jordan are among the earliest documents of Western civilization. So we want to estimate the age of the Dead Sea Scrolls if the animal skins on which some of them were written contained 78% of their original carbon-14. So when we go to plug this into the formula, we're not going to use 78%. We're going to change that over to a decimal. So we get 0.78 is equal to e to the negative 0.00012 t. Okay, and we're going to use the same steps that we did in the last video to solve for t. All right, so I want you to pause the video and try to solve this, and then we'll come back and check. All right, so if you take the ln of both sides, we'd have the ln of 0.78 equals the ln of e to the stuff. We know that ln of e cancels out, leaving us with ln of 0.78 equal to negative 0.00012 t. We can divide by the coefficient of t, giving us that the Dead Sea Scrolls are 2070.5 years old. All right, again, it's the same steps that we did to solve for how long it will take money to double or triple in an account. All right, another cool application here is learning theory. So your ability to do a task generally improves with practice. Frequently, if your skill after T units of practice is given in function form, we have S of T is equal to C times 1 minus e to the negative kt, where C and K are some positive constants. So, where this comes in handy. After T weeks of training, your secretary can type S of T equal to 100 times the quantity 1 minus e to the negative 0.25 t words per minute. We want to know how many weeks will it take for them to reach 80 words per minute. Okay, so we're looking for that t. The how many is the hint that we're looking for the t value. So I'm going to plug S of T equal to, plug in 80 for S of T, I should say. So 80 equals 100 times 1 minus e to the negative 0.25 t. And we're going to solve for t. The first thing that we need to do is divide by 100, because you've got to get the parenthesis by itself. So if we divide both sides by 100, we get 0.8 equal to 1 minus e to the negative 0.25t. Then we're going to subtract 1 and divide, or we'll subtract 1 first. We get negative 0.2 equals negative e to the negative 0.25t. And then we're going to divide by negative 1 because you've got to get rid of that negative in front. Dividing both sides by negative 1 leaves us with 0.2 equal to e to the negative 0.25t. So at this point, we're going to take the ln of both sides. So ln of 0.2 equals the ln of e to the negative 0.25t. Same concept as the example before. Ln of e, we know always cancels out. It becomes 1. So I have ln of 0.2 equal to negative 0.25t. And I'm going to divide by that negative 0.25. Again, when you're plugging this in your calculator, you want to make sure that if your calculator opens up a parenthesis for the ln of 0.2, make sure you close that parenthesis before you divide by the negative 0.25, or you will get a really funky answer. So when we divide this, we'll end up with 6.4, and again that'll be weeks, to get up to 80 words per minute. So after 6.4 weeks of training, the secretary should be at 80 words per minute. All right. The last example we're going to look at is social science and diffusion of information by mass media. So when a news bulletin is repeatedly broadcasted over radio and television, the proportion of people who hear the bulletin within t hours is the formula P of t equals 1 minus e to the negative kt for some constant k. And what's going to happen is, if at a certain amount of time, so when the broadcast first starts, no one's heard it, and then at some point it's going to level off, and it's going to look like it grows really fast with people hearing at first, and then at some point it's going to start leveling off to where as many people are going to hear it as are going to hear it. Okay? So, if a storm warning is broadcast and the proportion of people who hear the bulletin within t hours of its first broadcast is the formula P of t equals 1 minus e to the negative 0.30t, we want to know when 75% of the people will have heard the bulletin. So we're going to replace the P of t with 0.75. Okay, remember, anytime you're putting the percent into the function, make sure that you're changing it over to a decimal and not leaving it as a percentage. So we have 0.75 equal to 1 minus e to the negative 0.30t. All right, so I want you to pause the video, work this equation, and come back and check your answer. All right, if you work through this equation, you should have come up with 4.6 hours. So at the end of 4.6 hours, 75% of the people will have heard the news bulletin about the storm. All right, that's the end of 4.2. If you have any questions, let me know.